The Animal Crossing stock market can be one of the best ways to make money in game, but who wants to have to keep checking up on prices, waking up early on Sundays to hunt down Daisy Mae to wherever she ran off to this time, and dealing with picking up and transporting all those turnips? I don't. I need my sleep. So let's make the computer do it instead. The stock market in this game is pretty simple. You buy turnips on Sunday mornings from Daisy Mae at a certain price, and then Timmy and Tommy from Nook's Cranny offer to buy them back from you at varying prices throughout the week. All you have to do is sell them at a higher price than what you paid for them, and that's it. You make money. So let's automate all of that. First, we're gonna need a way to control the character so we can move around in game. For this, I searched around and eventually found a library that can make an Arduino act as a Pro controller when plugged into the Switch. Using this library, an Arduino MKR1000 that I had laying around, and this cable, I was able to make something that allowed me to send serial commands to the Arduino, which it would turn into controller inputs and send them to the Nintendo Switch. This meant that I could use pretty much any programming language that I wanted for the rest of the bot, and it would allow me to make things more dynamic later on. At this point, we can send inputs directly, but we need a way to consistently define sequences of inputs so that they can be reused. I made a function that would take a list of actions and turn them into controller inputs. Each action could have a list of buttons to press, the position of both analog sticks, and a duration. This made it easy to define things like directions for how to get to specific places and other actions that we'll need to perform. Now we need to be able to get to the store, since that's where we need to go to check the prices and where we're going to eventually sell the turnips. To define and code out the actions, I basically just did whatever I wanted to do and used my phone's stopwatch to get a rough approximation of the timings. After we're in, we just have to figure out the sequence of buttons we need to press to navigate the menu options and reach the current turnip price. At this point, we have to somehow read the screen to get the price, and to do this, we'll need a capture card. I have this cheap one that lags and stutters every now and then, but it'll work for what we want to do. The capture card takes in a video signal and plugs into the computer via USB, acting like a webcam. And a library called OpenCV lets us take that webcam footage and do stuff with it programmatically. Once we can see the game, we also need to be able to actually read what's on the screen, and for this, we need a technique called optical character recognition through another library called Tesseract, which uses AI to recognize text within images. Since we're only interested in the part of the screen with a turnip price, we'll need to first crop the frame to just that region. Then we can run Tesseract on this smaller image to recognize the text and finally convert it into usable numbers. With what we have right now, we can already make a script that automatically runs and grabs the current turnip prices for us, which is exactly what I did. I set this up to check the prices at 9 AM and 1 PM and went to bed to see what would happen. Small little detail. Every morning after 5 AM, Isabel comes up to greet you and say the morning announcements, so we're gonna need to deal with this. Since it's triggered when you enter or leave buildings, this can be fixed pretty easily. I just made it automatically go out of the house every day at 5 AM, skip the announcements, and go back in. After these fixes, I set this up again the following night. Okay, that worked. Good. So we got price checking. But we need to also sell these automatically when the price is right. This means we'll need to somehow find out when the best price during the week is. As it turns out, a data miner by the name of Ninja on Twitter published exactly how prices are generated. And since then, multiple tools have come up to help people get the most out of the market. Apparently, these prices aren't totally random. Instead, they follow a set of predefined patterns that are assigned to your island each week based on the previous pattern. There are 4 patterns that you can get: large spike, small spike, random, and decreasing. Without going into too much detail on how these work, the large spike pattern is the best one to get. It starts out decreasing, but prices spike up pretty high, guaranteeing a price that's 2 to 6 times what Daisy was originally selling them for. Next is small spike, which is kind of like the previous pattern, but values cap out at 2 times Daisy's price. In the random pattern, prices are all over the place, but if luck is in your favor, values can be up to 1.4 times Daisy's price. Lastly, the worst pattern of them all is the decreasing pattern, where prices will start below Daisy's price and they'll keep getting lower and lower each day. With this one, you're guaranteed not to make your money back, and your best bet is to sell at a friend's island. There's a lot more to how these work internally and how you can actually determine the best times to sell within each pattern. I'll link below this really nice Google Doc that has all this info in plain English and is highly detailed in case you're interested. In any case, with this information, we could make our own price predictor, but I'm just gonna not reinvent the wheel and just use one that already exists to power this little project. Stocks.io is a pretty nice one that even gives you a recommendation of whether you should sell or hold your turnips, and if you support them on Patreon, they'll give you a nice API to use. So I decided to go with that and just trust their recommendations. Knowing when to sell is cool and all, but we need to actually do this in-game. I chose to clear out a couple rooms and store all of my turnips inside my house, so selling is going to consist of going to each room, picking up and selling turnips from that room until the room is empty, and then going to the next room and repeating the process until we're done. Getting to the different rooms is pretty straightforward, and picking everything up should be simple. Just go around and press the pickup button until our inventory is full, right? Yeah, it turns out that this is much more tedious than I initially expected. To make sure we pick up what we actually want to pick up, the timings need to be pretty dead on so we land in a certain spot. If you're off by a little bit, you could instead pick up the item in front of you. To solve this, I made a custom design pattern and laid it out on the floor so we could see exactly where the cells that make up the grid were. Then I had to do a couple things like reducing some latency that happens between sending the command and the action actually taking place, moving slower so timing didn't have to be so perfect, and even overshooting at the end of the column to serve as sort of a position reset on the vertical axis. This took a lot of trial and error, but eventually I was able to get it to work pretty reliably. We also needed a way to get to specific cells so we could exit the room and continue where we left off when coming back from selling. So after quite a bit of trial and error again to fix timing issues, I coded out a function to do exactly that. Finally, we need to go back to Nook's Cranny to sell everything we picked up, but thankfully this was much easier than getting all those timings right. We just need to go into the right menu options and select everything we want to sell. I also made it automatically go to the ATM and deposit everything after selling to make sure that leftover money bags weren't an issue. Okay, at this point we can just leave the bot running and it'll track our prices and sell at the best time possible. But there's one last thing we need to do. The worst part of this whole thing is having to wake up on Sunday mornings to purchase the turnips in the first place. But there's a giant problem here. Daisy Mae doesn't have a set spot on the island, so we need to track her down, and doing this programmatically isn't so simple. Earlier on, we used computer vision and OCR to detect and read text that was on the screen, and now we'll need to detect Daisy Mae herself. I'd never done this before, but I knew object detection was a thing you could do with machine learning, allowing you to classify objects and images. So that's what we'll do. Since what we're detecting isn't really a common object to detect, we need to train our own object detection model. To do this, the first thing we need is a whole lot of images of Daisy Mae in different angles and lighting conditions. I took some screenshots myself, but to speed things up, I went on Google Images and downloaded all the decent images I could find. Next, we need to label these images by manually drawing a box around where Daisy is, so the model knows what we're looking for. After gathering and labeling all these images, it's time to configure and train our model. After a bit of research, I decided to use YOLO v3, which stands for You Only Look Once. It's a pretty complex object detection algorithm that sends an image through a convolutional neural network and gives us the location of where certain objects are in the image. I found this really helpful video by the AI guy that simplified all this and allowed me to train the model in the cloud. So I uploaded all my images and let the training begin. I let it train overnight and checked the results in the morning. I gave it some new images I hadn't seen before and it seemed to be working alright. But when I tried applying it to a video, it was completely unusable. It was incredibly slow and it wasn't detecting Daisy Mae at all. Apparently, I had a bug that ignored pretty much half of the training images, so I fixed that, tweaked some parameters, and switched to YOLO v3 Tiny, which is supposed to be faster but less accurate. I only ran the training for about an hour, but the results were already way better. It was detecting Daisy Mae pretty well, and the detection was running faster than before, but still not as fast as I'd hoped. I was using an extra library to run the model, but it turns out that OpenCV already has the ability to run YOLO v3 models, and its implementation is much faster. I tried this out, and while accuracy wasn't perfect, the speed was good and I was happy with the results. My CPU, on the other hand, was definitely not. For this object detection to work, Daisy Mae has to actually be on the screen, which is a problem since she can be anywhere on the island. Luckily, I found out that you can kind of force the location of most NPCs in the game by digging around the plaza. After doing this, they'll always spawn here and be constrained to moving around in this area. This means we just need to be in the plaza, and eventually Daisy Mae will walk in the frame. To be able to move towards Daisy, we also need to track our character. Fortunately, I remembered a video from Pieman Rules where he used the Luigi outfit in Super Mario Odyssey to track Cappy based on its color. I was able to use a very similar technique here, changing my hat to a really bright green color. This lets us separate out the red, green, and blue channels of the frame and simply select the most green part of the image. Using these detected positions, we can calculate where we need to move the analog stick to go to Daisy and press the A button when she's close enough to talk to. Unfortunately, there's a ton of variables here that make this less than accurate, such as inconsistencies and inaccuracies in the object detection, latency in the capture card, and latency in sending inputs. This means that it can take a while until it actually gets to talk with Daisy Mae, but since it'll always eventually get there, it'll be fine. What isn't fine is when there's other NPCs in the plaza, we could accidentally trigger them instead. To fix this, I just used OCR again to check the name of the person I was talking to and back out of the conversation if it's not Daisy. After interacting with her and doing whatever we need to do, we need to get back to the house to store turnips. Up until now, we've always controlled the character in a predefined way, so we always knew where he was. But since in this process he follows Daisy all over the plaza, he could end up at any random spot within it. I had to implement a position reset of sorts that moves the character down and to the right for an extended period of time at a speed that doesn't make him hop over the ditch, so we can be sure he'll always end up at a known position. Having all this figured out, we can implement the simpler parts of the purchasing sequence, like getting money from the ATM. I had to code out the ability to use the on-screen number pad to input the correct amount, but it was pretty straightforward. We also have to store all the turnips at home once we buy them, but dropping stuff is much more accurate than picking it up, so it shouldn't be too much of a problem. We just need to go to specific cells in each room and press the right sequence of buttons. And with that, we finally have all the parts to make this thing completely autonomous. So let's see it in action for its first full week. Okay, that's what I'm talking about. In a single week, we were able to buy everything and sell at the highest point for a profit of 9,868,800 bells without lifting a finger. So, was this worth it? I guess? When I started this, I definitely wasn't expecting it to go the route it did and having to end up learning about machine learning and object detection and all that stuff. It required a ton of tweaking and fixing things to prevent everything from breaking down, but I learned a lot and I'm glad I did it. If you'd like to see more videos like these, please let me know in the comments and subscribe to the channel. Thanks for watching.